Hello, this is the luckiest maths teacher in the world. Thank you so much for tuning into this video in which we'll look at signed areas. We're still looking at the area under a curve, but we're looking at positive and negative areas in this video. So we're going to illustrate the concepts using this example, calculate the area of this curve between x equals -1 and 1. So hopefully you know by now that the area under a curve is just the definite integral. So the area under this curve will just be the integral of x cubed minus x between x equals -1, x equals 1. So hopefully you know now to evaluate this, we take the antiderivative, evaluate it at x equals 1, x equals -1, and then subtract. So the antiderivative of x cubed, so remember we increase the power by 1 and then divide by the new power. Similarly, for minus x, we're going to increase the power by 1 and divide the new power. Remember, when it's a definite integral, you don't add the c. There's no constant of integration. Instead, we're going to evaluate this at x equals 1, x equals -1, and subtract. So substituting in x equals 1, I just get 1 over 4 minus 1 squared on 2. So that's x equals 1. Then I subtract when x equals -1. When I'm substituting a negative into this formula here, I must make sure that I use brackets. So if I'm putting this in my calculator, got to have the brackets around the -1, otherwise I'll get the wrong answer from my calculator. So if I do this properly, I put this in my calculator, the answer I get is actually 0. How can I get an answer of 0? How could the area under this curve be 0? Well, let's quickly graph the function to see what's going on. So this is what the graph of y equals x cubed minus x looks like. So when we're calculating the area under the curve, I know that's what I've been calling it, but really we have to view these definite integrals now as the area between the curve and the x-axis. We're actually counting this area here and this area here. That's what we found with the definite integral. So you can probably tell now why we got an answer of 0. Apologies for my bad drawing, but these two areas are actually the same, except this one here is positive and this one here is negative. So actually a negative area refers to an area that is below the x-axis. So when we're doing these definite integrals, we're actually calculating the area between the curve and the x-axis. If that area is above the x-axis, it's a positive number, and if that area is below the x-axis, it's a negative number. So these two areas cancelled each other out. That's why we got an answer of 0. So unfortunately, there's no way around it. We're going to have to slightly modify the way we calculate areas. If it's below the x-axis, we just have to times it by -1. So how would I actually go about properly calculating the area between this curve and the x-axis between -1 and 1? Well, I have to do two separate integrals. What I would have to do is I'd have to go the integral from -1 to 0. So from -1 to 0, that's this area here, will be calculated by that. Now, instead of adding, I need to subtract the area now from x equals 0 to x equals 1. So why did I subtract? Well, simply subtracting here, because this is a negative, means that I will make this whole thing into a positive. So I've got this area plus this area. Subtracting the integral when it's below the x-axis makes it a positive. So some of the work I've done up here will be useful. I know that the antiderivative is x to the power of 4 over 4 minus x squared on 2. That part hasn't changed, but I'm just going to evaluate it at different points. So here I'm going to evaluate it between -1 and 0. And here I'm going to subtract. I'm going to have the same antiderivative, but this time it's going to be evaluated between 0 and 1. So when I substitute in 0 here, I'm obviously going to get 0. So this first part is 0 minus. Now when I substitute minus 1 into here, I get minus a half. So this first part is 0 minus a half. That is this first evaluation here. So then I have to subtract. Now I'm going to do the same process here. If I substitute x equals 1 into this formula here, I again get minus a half. And if I substitute x equals 0, I get 0. So putting this into my calculator, you have to be very careful about all the minus signs. I get positive a half, positive a half. So of course a half plus half is just 1. So the total area in yellow is 1 square unit. It's not 0 as I originally thought. So when you're finding areas, you need to know when the curve is above or below the x-axis. But don't worry, you don't have to do heaps of algebra. You can use your graphics calculator. So if you've got a function like this one and you're not sure when is it above or below the axis, first, before you do any working out, put it into your graphics calculator. If you find that it is below the x-axis at any time, you need to do a separate integral for that interval like we did here, and it needs to be subtracted. Subtracting the integral when it's below the x-axis will make this a positive area, so you can just add the two areas and you won't get a situation like I had up here where they cancel each other out. For times when it is above the x-axis, you just evaluate the definite integral as normal. But you need to do times when it's above the x-axis separately to times when it's below the x-axis. You need to do separate calculations for that and use your graphics calculator to help you tell when it is above or below the x-axis. All right, thank you so much for tuning into this video. This has been the luckiest maths teacher in the world. Have a great day.